Alrighty, guys, we get to start a brand new unit, and it's one of my personal favorites to teach. I'm so excited about it. We're dealing with right triangles and trigonometry. So today's lesson is going to be about the Pythagorean theorem, which you should know. You may not know that's the name of it, but you should know what it is. And then we'll do something a little bit different with it that you may not have done before, but it shouldn't be too bad. It's actually a really short unit. There's 4 days of content learning, and then one day we'll do like an extension of the last day, and then there'll be a test. So this is really short. Okay, so let's get started with the Pythagorean theorem. So we all know that the Pythagorean theorem deals with right triangles, and it helps us find side lengths of right triangles. We know it works only for right triangles. You should know that by now. All right, so here's a generic triangle. Usually the letter C is listed up here, and I'll explain what that side is in a minute. I'm getting a little ahead of myself, but so we called the sides A and B. Those are called the legs. And then the side C we call this fancy word hypotenuse. And the way we tell that that's a hypotenuse is because a hypotenuse is always the side across from the 90-degree angle. So here's your 90-degree angle. You look across the triangle, that's going to be your longest side for any right triangle. It's usually labeled C. It doesn't have to be, but it's usually labeled C. Okay, then here's the Pythagorean theorem that you always know. A squared plus B squared equals C squared. Everybody knows this. That's what we're going to use for today. Let me scoot my paper up a little bit. And now what we'll do is we'll know 2 sides of a right triangle, and we're trying to find the third one, and we'll use this theorem. Now what trips kids up is they forget, or they mix up where to plug the sides into. And so I'm going to try and help you figure that out today. So always look where the X is at first. So it's right here. In this specific example, it's right here. And then look across the triangle to the angle that's there. In this instance, the 90-degree angle is across from the X. That means this X is the hypotenuse. Or you could call it the C value. Okay, so you're trying to find this now. And so the 2 sides you're given will go in for the A and the B in this instance. And so we'll do 8 squared plus 13 squared equals, we'll say C squared. Okay? Now I want you to write everything out. So we'll do 8 squared. So on a calculator, you just type in 8 and then hit this little X squared key over here. And we get that that's 64 plus 13 squared equals 169 equals C squared. And then we'll add 64 with 169. We'll get 233 equals C squared. Now we all know to take the square root. Okay, now I'm going to turn it around. So C should be the square root of 233. Now I want to stop right here for a minute. But I think the problems I've picked out for you on this note page, I think every answer is going to be kind of weird looking. You're not going to have any pretty answers. So I'm going to review this a little bit because I think we have trouble with this when I talked about it in the last unit. So if you type in a square root, first of all, you have to hit the second key and then hit the X squared button. That pulls up square root. And then we have to see if this thing is going to be pretty. What I mean by that is that when I type that in, if the answer is what I call pretty, we should have a nice whole number answer. We don't. We get this big god-awful decimal. So that is your clue that you need to attempt to come over here and use a factor tree to do that pair situation I talked about. Okay? If you want more on this square root topic simplifying, on the video lesson for similarity in right triangles from the last unit, in that video I specifically talk about square roots a little bit. So if you want more information on that, you can go back and watch that video, or at least the first part of it. All right, so now we have to see if we can break down 233. So we start dividing. Let's start with 2. That's not going to work. 233 divide 3. Nope. 233 divide 4. Nope. 233 divide 5. Nope. 233 divide 6. Nope. 233 divide, whoops, forgot one, divide 7. Nope. 233 divide 8. Nope. 233 divide 9. Nope. 233 divide 10. No, I'm going to stop there. You can go on and on and on and on. But the point is, for this specific problem, you don't have any pairs. So this will not break down any farther. So guess what? This is your answer right here. And notice the directions say leave it in simplest radical form. So I was trying to break it down, but I had no pairs. And so it has to stay like this. All right, let's do this again. So find x, leave the answer in simplest radical form. So look where x is at in this instance. Look across the triangle to the angle. Number one, I don't know what it is, but that's not important. The important thing is it's not the 90. So this is a leg. So we're trying to find either A or B. I generally just let it be A. It really doesn't matter which one you pick. So let's just say it's A. So instead of X, we could use X, or you could use A. It doesn't matter. I'm going to use A. So A squared plus, now what's the other leg? In this instance, it's 7, because 7 is not across from 90. Okay, so the other leg for B is going to be 7 squared equals C squared. And if you want, you could label this as B and C. Over here, we could have said A and B. That might help you, actually, if you label those as A, B, or C. Oops, I wrote C. We have a number there. Sorry. 9 squared. There we go. All right, let's simplify. A squared plus 7 squared is going to be 49. 9 squared is 81. We'll subtract 49. So A squared is going to be 32. I'm going to come up here. I'm running out of room. So we take the square root. So A is the square root of 32. So let's check. So type in square root 32. Remember, we're looking for either a nice answer or god-awful decimal. It's god-awful decimal. So that means off to the side, we need to try to do factor tree. And I think this one will break down. I know it does break down. So what multiplies to get to 32? Well, obviously you could do a 2 and 16, but let's pick something else. Let's start with 4 and 8. That's the first one I thought about. 4 breaks down to 2 and 2. 2's can't go any farther because that goes down to 1 and 2. That's kind of dumb, so we just stop at that. 8 is another 2 and a 4. And then, hey, look, 4 is 2 and 2. And then what I like to do is all these prime numbers, I like to list out underneath here. So 2 times 2, and it is all multiplied. 2 times 2 times 2. Let me try to separate that a little bit. A lot of 2's. So we have 5 2's in place of our 32. Okay, and now that we've done this, we need to pair up our 2's. So we can get a pair right here. And remember, if I'm going to come outside the square root house, I have to have a friend. That's why we pair up. So these get to come outside and play. Here's another pair. They get to come outside and play. You can have multiple pairs get to come outside. So this pair, that gives us 1 2 on the outside. This pair gives us another 2 on the outside, multiplied with the first one. Then we have one little lonely 2 left over right here. And so that is going to go underneath the square root. And we can simplify that to 4 square roots of 2. Okay? So these are instances where you have to leave your answer in simplest radical form. And I am expecting to see square roots in your answers on your homework. If I don't see square roots and you write me 42, or you leave it at 32, number one, if you leave it at 32, you haven't simplified. Number two, if you don't write 4 square root of 2 and put 42, that's just stupid. I need to see square root. Okay? And you need to simplify it if you can. Now, we're still doing Pythagorean theorem, but notice the directions say now round to the nearest tenth. So when we get to this point, we'll just type it in the calculator. We don't have to do factor trees anymore. Sometimes this will happen. Especially if it's in a real world context and you've got like, this is 22 feet or 22 miles, you would want to use the decimal. Okay, you don't want to say this many miles. That's dumb. So in more like real world instances, you'll use decimals. But all right, x is right here. So look across the triangle. There's 90. So this is going to be the c value, the hypotenuse. So you can let this be a or b. It doesn't really matter. So I'm going to say 22 squared plus 27 squared equals the c squared. 22 squared, when you type that in, is going to be 484 plus 27 squared. 27 times 27 is 729 equals c squared. Add these two together, you get 1,213. Now we take square root. So the c is going to be the square root of 1213. Remember, I want decimals, so at this point you can just type in the calculator. So we can say it is approximately, and then we'll type in the square root answer. So you just type in the calculator like that. And then you'll round to the tenth. So you're the first decimal place, look behind. You all know how to round at this point. So this is going to be 34.8. If you're asked to round to the nearest whole, you would look to the last digit before the decimal place and then look behind. That would round this up to 35 if you were to round that way. It just depends on what your directions say. I just picked 10th for these directions. All right. Here's x. Look across. That's not 90. So this is a leg. I'm going to call it A. That means, well, now you have to remember. 16, look across. That's not 90. So this is going to be the B. 27, look across. That's 90. So this is going to be the C. So let's set this up. A squared plus 16 squared equals 27 squared. So a squared plus 16 squared is 256 when you type that in. And then 27 is not that. It's 729. Subtract 256. Subtract 256. So a squared is going to equal 473. We take square root. So A equals the square root of 473. And you'll type that into your calculator. And you round it, it's about 21.7. Here's a good indicator on these kind of problems where you're trying to find the leg, or actually any of them. Whatever the value for C is, whatever your hypotenuse is, it should be the biggest side. Okay? So like on this problem right here, if I was unsure of 4 square roots of 2, type this in your calculator and get the decimal equivalent, and then compare it to the biggest side. If your answer here was bigger than the biggest side, you did something wrong. So you need to go back and check it. But this isn't. So anyway, that's a good idea to check your answers. All right, now we're going to look at something called the converse of this theorem. And converse just means you kind of state the theorem backwards. So the theorem says earlier, if it's a right triangle, then a squared plus b squared equals c squared works. What we're doing now is we're going to reverse it. So now, and I'm actually going to write it backwards a little bit. So I'm going to say if c squared equals a squared plus b squared. Remember, that's the theorem from earlier, just written backwards, and it's okay that I did that. If this is equal to this, then the triangle is the right triangle. Okay? And I forgot to tell you this. We use the converse of the Pythagorean theorem to classify a triangle. So what? Look down here. I've just given you 3 numbers that are sides of a triangle. You have to tell me if it's a right triangle, an acute triangle, or an obtuse triangle. Without drawing. Without drawing it, without knowing angles, all you know is the side lengths. And that's where this converse comes into play. So remember, if they're equal, it's a right triangle. What if they're not equal? Well, one option is the c squared is bigger than a squared plus b squared. So if the c squared is greater, then it's an obtuse triangle. Okay? The other option is if c squared is smaller than a squared plus b squared. So if it's smaller, then it's an acute triangle. Okay? And I purposely wrote these with the c squared first. It makes comparing so much easier. Okay? Most books have you compare from this side. Yeah, I don't like that. So I turn it around. This is much easier for you to do. Okay? So we're gonna check these 3, and if these should fall in one of these 3 categories. Okay. Go ahead and put it there. All right. So yes, mine are in numerical order on your problems. They may not always be. So what I always do is find the biggest one. So this here, 9's the biggest one, so we'll call that the C. Remember, the C is the bigger one. It's supposed to be the longer side. And then you can let the other ones be A, B. It really doesn't matter who's A and who's B. So we'll put C squared first. So 9 squared, and I kind of did this little divided dashed line right there to separate out what we're doing. On the other side, we'll do 3 squared plus 7 squared. All right, now we'll have to figure these out. So 9 squared is 81, 3 squared is 9, 7 squared is 49. Drop 81, add those 2 together, 58. Who's bigger? 81's bigger. So notice that it's the greater than sign, and so this is an obtuse triangle. That's literally it. Like this is easy. Make sure you put the biggest side first. Add the other 2 over here when you square them. Simplify, compare who's bigger, and then look up here, figure out if it's right, acute, or obtuse. Really easy. All right, 22 is the biggest, so that's going to be A and B. So 22 squared, put our division or our divided line. 17 squared plus 17 squared. Yes, those are the same length. It really doesn't matter. 484. 17 times 17 is 289 plus 289. 484. Add those two together, you'll get 578. Who's bigger? This side's bigger. And so if this side is bigger, then it's a cube. Or, sorry, I should have said this way. The c squared side is smaller. You got the less than sign, so this is a cube. All right, who's the biggest? 29. That means that can be A and B. So 29 squared, do our dash. 20 squared plus 21 squared. 29 squared, when you multiply that, that's 841. 20 squared is 400. And then 21 squared is 441. Add those two together. Hey, look, they're equal. So this is a right triangle. Last one. Between the three, 30 is the biggest. So 30 squared, do our division. 18 squared plus 24 squared. 30 squared is 900. 18 squared is 324. 24 squared is 576. I have a lot of those squares memorized. That's why I'm just popping them off. 900. Add those two together. Hey, they're equal. So this is a right triangle. All right, that's really it. I mean, this back side should have been the newer side, because I don't know if you've technically done this before. But you saw how easy it is. It's literally you square and add, compare who's bigger, match it up with one of these, and then use the right name. That's literally how easy it is. The front should not have been brand new. You've done Pythagorean theorem before. But that's it. That's all there is. So remember, watch this video in its entirety and then complete your homework assignment. I think there's 16 problems on it, and I'm asking you to do them all. Everything I've done on these notes, there's an equivalent problem in the homework, so you should be okay. But if you run into any issues, as always, please let me know.